video, we're going to focus on what's called vectors in the plane. So vectors in the plane. By the plane, we mean the xy plane. So if v, and usually when you write vectors, you're supposed to put like a little line here. Okay, so sometimes I'll put the arrow, sometimes I won't, but it's supposed to be there. So if v is a vector whose initial point is 0, 0, so the origin, and terminal point is, say, parentheses v sub 1 comma v sub 2, then we say that v given by angle bracket v1 comma v2 angle bracket is the component form of the vector v. So is the component form of v. So if you have a vector that's written in this way, we say it's written in component form. And these guys here, so v1 and v2, these guys here, these are called the components. You can think of the first one as x and the second one as y. We're just being a little bit more general here when we call them v1 and v2. So let me give you a picture so you see what's going on. So here's the pic. So here we have the y-axis, and here we have the x-axis, so x, y. And then maybe this is the initial point, and then this is the what's called the terminal point. So this point here would be v1 comma v2. And so our vector would look something like this. Okay, and that would be our vector v. So you could say v in this case is the vector whose first component is v1 and second component is v2. Since the initial point here is at the origin, I did that on purpose, then we say that our vector is in standard position. So this is a vector in standard position because the initial point is the origin. Okay, so let me go ahead and write that down. So since the initial point is the origin, we say the vector is in standard position. We say the vector is in what's called standard position. So standard position. Okay, lots of terminology, but it's good stuff. It really is. Just a quick aside, or just another remark actually. The vector with initial point 0, 0 and terminal point 0, 0 is called the zero vector. So note the vector with initial point and terminal point zero, 0. So the initial point is the same as the terminal point, and they're both 0, 0, is called the zero vector. It's a very important vector in Calculus 3 and in mathematics. It's called the zero vector. Okay, we're going to use it a lot. And the notation for the zero vector is a 0. Right, it's a 0, but since it's a vector, we put a line with an arrow above it. And the first component of the zero vector is 0, and the second component of the zero vector is also 0. So very special vector in the world of vectors. Let's look at another picture that's going to prove to be useful, especially later on if you're trying to understand the derivations of some of the formulas in Calculus 3. So a worthy picture. So consider the following picture. Okay, say we have a vector here, starts here and ends here. So I'll connect the dots and draw the vector. And say the initial point here, in this case, we'll call it P. And I'll say the components of P are P1, P2. So it's not a vector, sorry, I said components. The coordinates of P. So the x-coordinate of the point P is P1, the y-coordinate is P2. Then here we have another point Q, this is our terminal point. And the coordinates of this point are Q1, Q2. So this is the initial point here. So P is the initial point. Initial point. And Q is the terminal point. Terminal point. Okay, so we have a vector with initial point P and terminal point Q. Okay. And the idea is this: to find our vector v, here's the thinking you want to go through in your head. V is always going to be, I'm going to put this in quotes, it's always terminal minus initial. You can always do that every single time, all day long, right? Terminal minus initial, terminal minus initial. So more formally, to find the vector v, what you do is you take the terminal, so Q1 minus P1, so you subtract the first components, okay, so Q1 minus P1, and then you subtract the second components, so Q2 minus P2. You can always do that, so Q2 minus P2, okay, and that gives you your vector, right, and this is V1 comma V2, so we're saying that this here is V1 and this here is V2. This is super useful. Okay, extremely kind of emphasize how useful this thinking is. So if you ever have an initial point and a terminal point, it's always terminal minus initial to get the vector. All right, there's a couple formulas. Sometimes we're interested in finding what's called the length of the vector. So the length, it's also called the norm. Okay, it's also called the magnitude. So lots of names for the same thing. So the length norm slash magnitude of a vector, let's call our vector v. In component form, it would be, I suppose, v1 comma v2 is, and what you do is you write these two double bars and you put the v here, double bars, and it's the square root of the components squared, so v1 squared plus v2 squared. Okay, that's the length norm or the magnitude of a vector. If the magnitude is 1, or if the norm is 1, or if the length is 1, depending what you want to call it. So if you have a vector with magnitude 1, whenever that happens, you have, then v is a unit vector. Then v is a unit vector. Really important. And the reason it's important is because unit vectors are nice, right? Whenever you have 1 as the magnitude, it simplifies the formulas, right? Simplifies them tremendously. So let's just do a really simple example of computing the magnitude, just a simple problem. Say we have the vector v equals 1 comma 2. So in this case, if we wanted to find the magnitude, what we would do is we would just square the components and take the square root. So the magnitude of v in this case, it's the square root of 1 squared plus 2 squared. Okay, so you just do 1 plus 4, and so you get the square root of 5, and that would be the magnitude. In this video, we have a vector written in the plane, and we have to find the component form of this vector, and we also have to sketch the vector with its initial point at the origin. So this problem may be simple, but it does illustrate a super important concept. So let's go ahead and write the component form down first. So the component form of our vector, which I'll call v, is equal to angle bracket, and there's a formula. It's always terminal minus initial. So terminal minus initial.
So in this case, you look at the terminal point, that's this one, that's where it ends. And this is the initial point, this is where it begins. So it's this one minus this one. So you subtract the components. So you do 5 minus 1. So I'll write it 5 minus 1, comma, and then 4 minus 2. 4 minus 2. So you subtract the x components and you subtract the y components. So the first components and the second components. Terminal minus initial. So we end up with v equals, this would be 4, comma 2. The question doesn't ask, but if we wanted to write it as a linear combination of I and j, so if you know what that is, you could write it like this, 4i hat plus 2j hat. And as a refresher, I hat is this vector here. It's called a unit vector because it has length 1. And then j hat would be this unit vector here. These are called the standard unit vectors. Anyways, this is not what we needed in this problem. Okay, so now we have to sketch this with the initial point at the origin. It's a pretty easy sketch. I'll do it over here. So there's the y-axis, there's the x-axis. So 4, 2. So you just go right 4 and up 2, and you put a dot there, and that would be your vector there. I hope this video has been helpful. Find two vectors u and v whose initial and terminal points are given. So we have a vector u whose initial point is 2, 0, and terminal point is 6, negative 2, and a vector v whose initial point is 5, 7, and its terminal point is 9, 5. Then there's a follow-up question that says, are the vectors equivalent? Two vectors are equivalent if they have the same magnitude and direction. So let's go ahead and find u and v. So to do that, all we have to do is subtract. The formula is always going to be terminal minus initial. So we take this point and subtract it from this point. And you just subtract the coordinates. So you do 6 minus 2, so 6 minus 2, and then you do negative 2 minus 0, so negative 2 minus 0. So this is going to give us, let's see, 6 minus 2 is 4, and negative 2 minus 0 is negative 2. So that would be our vector u. So let's just check that. 6 minus 2 is 4. Negative 2 minus 0 is negative 2. Good stuff. Let's do v up here. So it'll be 9 minus 5, which is 4. I'll go ahead and, well, I'll show the work. 9 minus 5. And then 5 minus 7. So 5 minus 7. This will be 9 minus 5 is 4. 5 minus 7 is negative 2. So this is our vector v. So we have our vector v. These are exactly the same vector, right? It's the same components and everything. So yes, they are equivalent. So two vectors are equivalent if they have the same magnitude and directions. You might say, well, they're the same, so obviously they're equivalent. The question is really asking about these, right? These vectors here, u and v, are the same as these. It's the same vector. It's just in a different place. So this vector here, you go right 4 and down 2. So 1, 2, 3, 4, 1, 2. Looks like this. Right, same as this one. So what are these? They're the same thing, it's just they're somewhere else. The initial point here is 2, 0, and the terminal point here is 6, negative 2. So it's just like you've taken this vector and you've put it in a different position on the plane. So it's the same thing. I hope this video has been helpful. Find two vectors u and v whose initial and terminal points are given. So we have the vector u with initial point 3, 2 and terminal point 5, 6, and the vector v with initial point 1, 4 and terminal point 3, 8. And we have to find the vectors and determine if they're equivalent. So to find the vectors, all we do is we subtract. It's always terminal minus initial. Terminal minus initial. So for u, it would be 5 minus 3. So 5 minus 3. And then you subtract the second coordinate, or the y components. So 6 minus 2. So 6 minus 2. So this is equal to, let's see, 5 minus 3 would be 2, so angle bracket 2, and 6 minus 2 would be 4. So 4, and there is our u. So that is our first vector, u. It's really, really important, the whole terminal minus initial thing. You might think, oh, it's really simple. It's important for understanding later. Like if you want to understand certain derivations in Calculus 3, it's really important to have this notion of terminal minus initial like down. So v, so it'll be terminal minus initial, so 3 minus 1, so 3 minus 1, and you can skip steps, I'm just showing extra steps, and 8 minus 4, so 8 minus 4, beautiful stuff. So v is going to be equal to 3 minus 1 is 2, and 8 minus 4 is 4. Oh, look, They're the same. So the answer is yes, they are equivalent. So you might be wondering, what does that mean? What does it mean to be equivalent? So two vectors are equivalent if they have the same direction and length. In other words, when you write them like this, they're going to be exactly the same. So this is a vector whose initial point now is at the origin. So we took this vector in the plane and we kind of shifted it down to a vector whose initial point is at the origin. So if you were to sketch this vector, it would look like this: 1, 2, 1, 2, 3, 4. And so that would be the vector. So these vectors here are the same, except they're in different places on the plane. But they all have the same length and direction, therefore they're equivalent. So if you get a different answer here, the answer would be no. So I hope this video has been helpful.
Find a unit vector that has the same direction as this one. So to find a unit vector in the direction of this one, all we have to do is take this vector here and divide it by its magnitude. So we'll start by finding the magnitude of this vector. So to do that, the formula is that it's the square root of, and then you just take each component and you square it. So it's 9 squared plus -5 squared. Just square each of the components. So 9 squared is 81, and -5 squared is 25. If you add these numbers, you get 106. So this is the length or the magnitude of this vector. So to find a unit vector that has the same direction as this one, we just take this vector and we divide it by this. So basically, you just divide each component. So it would be 9 over the square root of 106, comma, -5 over the square root of 106. And this would be a vector that has the same direction as this one, but this is a unit vector. That means that the length of this vector is equal to 1. I hope this video has been... Find the magnitude of the vector v equals 2i plus 3j. Solution. So the formula for the magnitude of a vector is the square root of a squared plus b squared, where v is equal to the vector whose first component is a and its second component is b. So in this problem, we can write this vector in component form, so 2, 3, and then just use the formula. So let's go ahead and do it. So the magnitude of v is the square root, and in this case, a is 2 and b is 3. So 2 squared plus 3 squared. Super easy. So 2 squared is 4, and 3 squared is 9. So we end up with the square root of 13. And that's it. We're being asked to find the vector v with the given magnitude. So here the magnitude is given to be 4. So this is the magnitude. And same direction as this vector here. So let's work it out. So first, we will find a unit vector in the same direction as u. So we will find a unit vector in the same direction as u. That'll be the first step. So step 1, we'll find a unit vector in the same direction as this one. And step 2, we'll multiply our result. So multiply our result, our new vector, by 4. And then we'll be done, right? Because then we'll have a vector in the same direction as u with magnitude 4. So first, let's find the unit vector in the same direction as u. So the formula for that is u divided by the magnitude of u. This will be a unit vector in the same direction as u. So you can write this as 1 over the magnitude of u times u. So this is 1 over, now the magnitude of u is the square root of, and you just square this, so 0 squared. You add, and then you square the 3, so 3 squared. 3 squared, that's a 3. And then u is 0, 3. So this is 1 over the square root of 9, and then we still have 0, 3. So this is 1 over 3. And we still have 0, 3. And finally, just distribute. 1/3 times 0 is 0. And then 1/3 times 3 is 1. So there is our unit vector in the same direction as u. So that was step 1. Step 2, we'll just multiply this by 4 and we'll be done. So finally, make it seem like a long problem, is 4 and then times our vector. So this will be 4 times 0 is 0, and then 4 times 1 is 4. So that is the final answer. I hope this helps. We're given two vectors, and we're asked to find the angle between them. Let's go ahead and do it. So there's a formula. It basically says that the cosine of the angle between the vectors, which is called theta, is equal to the dot product of u with v divided by the magnitude of u, and that's being multiplied by the magnitude of v. So we can do this all at once, or we can do it one step at a time. Let's do it one step at a time. So if we look at u dot v, well, to compute the dot product, we multiply the corresponding coordinates. So we multiply the first components, so 3 times 2. And then we multiply the second components, so 1 times -1. So plus 1 times -1. This ends up being 3 times 2 is 6, and 1 times -1 is -1, so we get 5. So the dot product of u with v is equal to 5. Let's go ahead and find the magnitude of u. So the magnitude of u, that's equal to the square root, and you just square the components and add. So 3 squared plus, and then 1 squared. So you end up with 9 plus 1, which is equal to 10, so the square root of 10. To find the magnitude of v, it's the same thing. You square the components and add. So it's the square root of 2 squared, so 2 squared, plus, and then the second component is -1, so -1 squared. So we end up with 4 plus 1, which is equal to the square root of 5. I think now we're in a good place to go back to the formula. So this is equal to, let's see, u dot v, we said that was 5, so 5. The magnitude of u, well, that's the square root of 10. And the magnitude of v, well, that's the square root of 5. So this is equal to 5 over the square root of 50. This is equal to 5. To simplify the square root of 50, the way I do it is I ask myself, what is the largest factor of 50 that's a perfect square? Well, 25. So this is square root of 2 times the square root of 25. So this is 5 over the square root of 2 times 5. The 5's cancel, so we get 1 over the square root of 2. This can be rationalized. You multiply by the square root of 2 over the square root of 2, and so we get the square root of 2 over 2. So we have that the cosine of theta is equal to the square root of 2 over 2, and that means that theta is equal to pi over 4. That's the angle we want that's between these vectors. I hope this helps. We're being asked to find the dot product. This is extremely easy. So we have the vector u, and we're finding the dot product of that vector with the vector v. So this is equal to the vector u, which is 3, 6, and we're taking the dot product of that with the vector v, which is -2, 4. And so to find the dot product, you just multiply the first components, so 3 times -2, and then you add, and then you multiply the second components, so 6 times 4. So again, you just multiply 3 times -2, so the first components, and then you multiply these second components, so 6 times 4. 3 times -2 is -6, and 6 times 4 is 24. So -6 plus 24, that's going to be equal to 18. And that's how you find the dot product of two vectors. That's it.
Hey everyone, so in this video we're going to find what's called the dot product of these vectors. So to find the dot product, you write u, and you put a dot, and then v. All you have to do is multiply the x's and add, and then multiply the y's and add. So you do 4 times 2, then you put a plus sign, then you do 6 times 8. That's it. So it's just 4 times 2 plus 6 times 8. 4 times 2 plus 6 times 8. 4 times 2 is 8. 6 times 8 is 48. So that gives you 56. And that's it. That's how you find the dot
Being
product.
asked to find the dot product, except we're not given the actual vectors. Instead, we're given the magnitude of the vectors and the angle between them. So there's a formula. It says if you have cosine theta, this is equal to the dot product of u with v divided by the magnitude of u times the magnitude of v. So we can solve this equation for u dot v. So u dot v is equal to, well, if you multiply both sides by the denominator, you end up with the magnitude of u times the magnitude of v times cosine theta. And now we can just plug in all of the given information and we're done. So the magnitude of u is 6, so this is 6, times the magnitude of v, that is 3, so 3, times the cosine of theta, and we're told theta is equal to pi over 6. So this is equal to, let's see, 6 times 3 is 18, and the cosine of pi over 6 is the square root of 3 over 2, and 2 goes into 18 9 times, so we get 9 square root of 3. And that is the dot product of u and v. That's it.